I'm glad that standing on the turntable in the video game gives you the same weird disorientation that you get on the real turntable, where you're like, why is the whole world moving?
All right. All right. We're gonna do a candid intro here for this one.
I mean, I guess we could do that. Been stealing your intro too much lately, anyways, because I forget to record my own.
Sometimes candid's fun because you just get right into stuff.
Oh yeah, we're gonna run trains today, guys. Last time we just ran light locomotives, and that's only so exciting because I mean, there's no chance.
Well, I've been here for 24 hours firing up the goat. I don't know about you.
Oh, good man. Yeah, I came in at 4 a.m. yesterday, and I've been.
How
here
long
since.
would it take to fire up an engine if you had to go? Engine's got to be moving ASAP, Rocky, like get her going.
Man. So I mean, if you're old school railroading the hell out of the thing, couple hours maybe, hour and a half to pressure.
And that's just what, throw as much crap in the firebox to get it burning ASAP.
Get a big fire. Like you take your time getting the fire built and then built up because you don't want to choke it. But once you've got a fire established, you toss a forced draft on it with a fan on the stack, or you hook an air line from the shop or a steam line from the shop into the blower, and then you just open that thing wide and just keep feeding it fuel. And that is atrocious for the boiler. But, you know, back in the day when you had to make money and you had to have locomotives, I mean, if you didn't have another one steamed up.
You just got to get the temp up as fast as possible. But then obviously you're going to cause issues with, temperature differentials throughout the steel.
I've heard
cold on one side and hot on the other. And
I've heard stories of locomotives that got fired up as fast as they could just to make sure that, they could get out on the road and fix whatever the problem was. And the safety valve's popping, but you could put your hand on the boiler sheet. That's how cold it was still. Which is just like gross.
It was basically just pressure only building up in the one spot, and
Well, so you'd have 200 psi-ish, whatever it runs at, to get the safety lifting on the inside of the sheet, and then across the 3/4 of an inch or 5/8 of an inch of steel or whatever it is, you go from that 200 degrees or 200 psi, 400 degrees-ish Fahrenheit to 90 degrees Fahrenheit-ish, like that temperature gradient, which is atrocious for the steel. I mean, boilers...
it would kind of warp and stuff, wouldn't it?
Boilers are only fixed at the front of the locomotive, at the cylinder saddle. That's the only place, asterisk, depending on the locomotive design. Most common locomotives are only fixed at the saddle. And they sit on kind of skates or swing links at the back because the boiler gets almost an inch longer for larger locomotives when it gets up to that temperature and pressure because of the expansion of the steel. And so if you rush that,
it would push towards you guys.
Yeah, it comes towards the cab.
All the valves, how do they deal with the fact that the hoses, there must be flexible hosing then, right? Because it's all going to move.
Well, so everything grows with the locomotive and the temp grows with the locomotive. So you might have stuff that leaks when cold, but when it heats up, it seats up and it doesn't leak. Between the engine and tender, there's hoses.
The disconnect from the temp difference. Could you have a rivet completely disconnect or something like that? Because it's
probably
too hot?
Not completely, but if you had a quick enough fire up, you would stress the bolts enough that you could start breaking stay bolts, and that has happened at rail. I mean, that's probably happened to every steam engine in existence at some point, unless it's a brand new build or something. That is just the name of the game sometimes if the railroad was trying to get out there and get these things fired up quick, particularly with the older style boilers. We talked about rigid stays versus flexi stays a couple episodes ago, so the flexis can handle it better, but the rigid ones, I mean, you're very, very likely to break those.
What about modern diesels? Is it turn a car key and then the thing goes?
I mean, it's a little bit more than just turn a car key, but for all intents and purposes, yes.
I mean, do they have a starter on them, an electric starter, or is it actually some sort of crank system?
It depends, and this is actually a really fun topic that I'm glad you brought up. So there's the two manufacturers of locomotives, primarily these days, EMD and GE. And while we talk about this, a couple episodes ago, I mentioned that GE bought Alco, and I pissed off the Alco foamers. Rightfully so, I'm sorry, I goofed. I didn't actually realize that GE did not buy Alco, but they were in a partnership briefly. And so a lot of their designs were really similar because of the partnership and everything. And And when I had heard about, I'd worked on an Alco and it had an engine that looked just like a 7FDL on the GEs that I'd worked on, and I made an assumption and I was wrong. So my apologies on that. But anyway, two major manufacturers of EMD and GE. GE does the smart thing, I think, and they use the alternator as the starter. They just run power through what they use as their alternator later, once the engine's running, and then that turns over the engine, so you don't need any extra parts.
So their alternator's like a big DC motor then?
Yep.
So you can run power through it, or you can use it as an alternator to generate power.
Exactly. It's just like the traction motors are too.
And what is it? It's chain driven then, or is it a big belt? It has to be a chain, right? Like there's
no
no way.
So they're not directly coupled. There's a flex coupling. They're in line, the alternator and the actual engine. And so the crankshaft of the engine runs to a flex plate of some variety. It's different depending on which manufacturer, of course. And then that flex plate is what bolts directly to the alternator.
Are the engines, so the engine running straight into the motor, is there a gear reduction there? Or is it just like big diesel crankshaft right in the motor?
Crankshaft, flexible coupling, boom, done.
Motor.
Yep.
That's it.
Well, it's not a motor, but it's the alternator.
A giant it's a giant DC rotor and stator, right? Like
well, yes, rotor and stator. Yeah, that's a good way to put it.
It's just, that's what I'm calling a motor. But yeah, it's only a motor if it's, going one way, and it's a generator if it goes the other way. If we're gonna be electrical engineers, we should be electrical engineers.
Well, it's the nuance.
Do some of that black magic stuff.
The nuance being that it's not actually a generator; it is an alternator, because to actually generate power, it does need an excitation supplied to it.
Right.
So there's a separate companion alternator in the case of GEs that makes that happen, and then in the case of EMDs, they have a separate auxiliary generator that then supplies that excitation.
And then it's big diesel engine goes to big alternator, which then provides big amount of power to multiple electric motors, which are then straight drive to the wheels.
Yes, yeah, there's gear reduction from the motor
gear
to
reductions anywhere.
There is a gear reduction from the motor to the wheels. There is a gear
but
case
it's
there.
Fixed. It's a fixed gear ratio.
It is
you can't
fixed,
change.
Correct. And they're designed differently for different applications. Like passenger diesels have higher gearing than freight ones and stuff. So that's a thing. But the difference in starting comes with EMD, where EMD tends to have a couple different styles. Some of the old stuff did start like the GEs, where they use the generator in that case, because the ancient EMD stuff actually had giant generators, which got very inefficient very quickly, which is why they went to alternators. Anyway, but most of the EMDs either have a pair of giant Cat electric starters manufactured by Caterpillar these days, turning a huge ring gear that is mounted to that flex plate we were talking about, or they have air start, where they have a gigantic third main reservoir, and that third main reservoir holds a ton of air that they just dump through a giant pneumatic motor that is then bolted to that same ring gear. And so the air start was always fun because it was an extra thing to lock out, tag out, because you needed to make sure that there was no air to prevent the engine from rotating. And also, they were always fun because invariably you'd take them out to test them, and you wouldn't have any air, and then you couldn't start the locomotive.
Would the air bleed over time, and then you'd be stuck with you hook it up to an air compressor and let
you'd hook it up.
fill?
Theoretically, you're always next to another locomotive. You can always charge it if you're at a shop from some system, but we would always invariably forget, because we'd only once in a blue moon get a locomotive with air start into the shop. So it was like, okay.
Right. So the electric starts, locomotives that must just have a massive battery pack then.
They have two huge 32-volt batteries. There might be more than 32-volt, because the whole thing runs, the whole locomotive runs on 74 volts, so they must be different.
So even the big drive motors run on 74 volts, but they must be a massive amperage.
They're gigantic batteries. Two of those batteries in the locomotives, I mean, you need a forklift to put them in. They're huge.
Right.
They are, if I had to guess, one of those batteries is bigger than the V8 in my Pontiac, and I have a 400 cubic inch V8 in it. I mean, they're huge. They're the size of a small pallet.
power is a pretty simple equation. I mean, wattage is equal to voltage times amperage.
Yep.
And, you know, it's a pretty simple equation. 1 horsepower is what, 500 something watts, 600 something watts? I don't remember the number.
550, I want to say, if I'm remembering things right.
Something like that, 600-ish. And so if you want to move something with 1,000 horsepower, you need 550 kilowatts, which is on 74 volts, a holy buttload of amps.
Yeah. So the fun.
Big battery.
The fun of these EMD locomotives comes in, and the folly of the railroad comes in with efficiencies and trying to make things better and save money. A story as old as time. And so EMD built the locomotives and designed them to just be, you know, run, and they're fired up and they're up because that was kind of what we did with steam engines. We just had them fired up and they would be up, and then when we would need to maintain them, we would take them down and they would be down. Kind of binary. They don't like to start. So one of the most...
were there any locomotives back in the day like that had external starters at all, or all the modern locomotives like they're all internal starting mechanisms? Like no one. Oh well,
so the starters on these EMDs that I'm talking about are external starters. They are external, running a giant ring gear that's outside the engine. You can see them plain as day on the side of the block.
Each locomotive has its, like, I'm talking more like if you look at like aircraft, sometimes there's aircraft where you have to hook it up to like an APU, you know, an auxiliary power unit, which is like a whole other generator that fires up with a turbine before the actual main engine starts. You know what I mean?
No, not that I know of. We've definitely started locomotives with other batteries, which is kind of the only equivalent thing I could think of. But yeah, that would be like the only similar thing.
But you never have to bring like an external generator up, hook it into the thing, and then like
not unless you were jumping a dead locomotive.
Right. Yeah. Okay.
Yeah. So the folly of the railroad was they learned that diesel engines use lots of fuel, and the more that they sit idling, the more fuel they use. And so they realized that they could save a lot of money if they would stop idling locomotives all the time. So they just turned them off and on. No, they put an automatic engine start-stop system on them called AESS, automatic engine start-stop. And if you had enough battery charge, enough main reservoir pressure, so enough air, and the engine temp was high enough, the locomotive would shut down automatically. And then when one of those parameters fell out of spec, it would automatically restart it. And so you went from a locomotive...
Would it check to make sure like the brakes were tied so you're not shutting off?
That is up to the locomotive engine being on or off has nothing to do with the brakes being set or not. That is up to the crew to properly secure their equipment, which is one of the big things the FRA looks for.
What if you're like coasting down a hill? You could shut off the locomotive as you're coasting?
Oh, it does check if you're moving or you're under power and all that stuff. No, it won't auto start then. If your reverser is thrown into forward or reverse, it won't do it. It's only if you're in neutral. That's my apologies for assuming that that would have been.
But what if you're in neutral going down a hill, or does it have a sensor that says no, you're in
You should
motion?
never be in neutral. You should always be in a direction thrown. But it can sense speed too, so that might be tied into it.
Standard either, but you know sometimes you got to do what you got to do. You know what
I
mean?
Well, there's literally no reason to on a diesel locomotive because you have to have the reverser thrown for the dynamic brakes to work. So
I see.
Yeah. So it's a whole
You're going
thing.
down a hill with the reverser in forward, and then in a notch, and then it's automatically throttling back because it's obviously not applying throttle to go down the hill.
Yeah, so you'd be in a notch on dynamics, which does run the engine harder, but that would be that rather than the throttles in any notch or anything.
So it'll try and provide power to the motors to slow them down rather than speed them up.
So the motors are generating power, which is what slows the train down in dynamics. Yeah, that you turn them into generators, which then causes a huge resistive load, just from generating power that slows the train down, and it's pretty impressive, particularly at speed. But anyway, the AESS system would shut the locomotive down and then cycle it as it needed to, and so invariably you end up with locomotives that start like 10, 12 times a day. And then all of a sudden, all the original EMD spec starters are just exploding all the time, and then locomotives would come in with dead starters. Always. That was like one of the most common failures we had was, starters are dead, or the write-up would be dead won't start, and then you'd look and you'd put power to the starter and nothing would happen, or smoke would come out, or one of the things is wrong, and it's like, okay, well, new starter time. And so Caterpillar developed a high torque, high cycle starter that helped alleviate the problem a lot. But it's like, oh, this is a new problem we've created for ourselves. Instead of saving money on fuel, we're now spending money on new starters.
Did they end up going back to it, or do they still use it?
They still use it, and it actually does make sense, and it really makes sense on the big GE power, and they actually come with it standard. The EMD stuff all had it kind of modified in, which is also kind of how EMD got the nickname of every model different rather than electromotive division, because every single engine's been modified so many times that nothing is to spec, nothing is to print, nothing makes any sense anymore, and good luck, Godspeed, figure out the problem.
It's so crazy to me how much energy, it's I understand as we get better, technology gets quote unquote simpler, but
right.
like a diesel locomotive by comparison to a steam locomotive seems so much easier, even though like it's obviously not, but like you know, it just seems like, oh, it's just a big car engine that, a big truck engine that then runs a big generator, which then runs an electric motor like you've got, anywhere, like easy peasy,
Yeah.
And then, yeah, it's really much more complicated. But like, just compared to like all the valves and timing, and I'm sure like there's a ton of that stuff on a diesel too. You just don't see it all because really it's just like I have throttle.
Show it to you. Yeah.
Yeah. I give you throttle and it just goes, and that's fine. Like
there's a lot of fun stuff that happens behind the scenes to make it happen, just like your car, right? And it's kind of like looking at a carbureted car versus a fuel-injected car. I mean, that's not the same steam to diesel, but it's kind of that thought process of we're adding more systems, making it more complex, but making it more user-friendly. And to that end, that is another big difference between steam and diesel that I haven't really talked about on the channel too much, which is troubleshooting and repairing things. It's much similar and akin to the diesel locomotive will start a train it can't pull, and the steam engine can pull a train it can't start. Well, the same thing kind of applies to troubleshooting and fixing. You can't really troubleshoot what the hell's wrong with the diesel locomotive, but you can fix it really easily. And the steam locomotive will tell you exactly what's wrong, but it's going to be a lot of work to fix it.
Yeah.
So it's the same kind of oddity where you'll be searching an electrical gremlin for days, different electricians. No one can figure out why this locomotive doesn't load, doesn't drive, or you turn it on and it starts loading, like it starts trying to drive as soon as you turn it on. Like, why is it doing that?
They're all computer controlled now, right? Like they'd have to be. Everything is all the throttles and stuff.
Not all of them. The more modern day ones, yes, but we still have plenty of stuff in service that's entirely relay logic.
So it's just like you put switch forward, I rev engine up regardless of consequences, basically.
Yeah, and then when things short out and things break and relays fuse and get stuck, sometimes you have the fun one. Like we had our shop switcher, ancient SW something, I don't remember, the GN 3436. Somebody look at it, or not 3436, 3606. Sorry. Look it up if you want the details on what kind of locomotive it is. But that was our shop switcher at Interbay, and it failed the one day where as soon as you would turn it on, you would put the knife switch in to give battery power to everything. It would start drawing like 800 amps to the traction motors trying to move it. And so you'd close the knife switch and it would try and weld itself shut because of the amount of current that everything was going on. And it was because it was modified to also work in a jog mode where you could run the motors without the engine running, so that we could move it in and out of the shop without any fumes and stuff like that. So that was how we moved dead locomotives around. And something electronic broke real bad, and that was a whole thing. So, yeah, good luck troubleshooting that, and and then you fix it. It's just one part and 4 bolts, and boom, done. But
if you have a diesel locomotive and you run it with so most diesels, they can't run with just the electric motors off the battery, like it won't let you do that?
All the GE locomotives, you can actually like plug an electronic Xbox controller looking thing into the side of them, and then you can jog them, but the EMD locomotives off the battery power only. The EMD locomotives... How long
does that last? Like 5 minutes, then your batteries are dead?
Pretty much, yeah. It's not long.
It can't be long.
It's enough to spot in the house and move things around in the shop and do all that fun. But you're not going to pull trains with it.
And charge your locomotive up, or do you just turn itself? Like you got it. Like what if the battery and you're in the shop? Can you plug it in and have it like actually?
We have trickle chargers just like you'd have for your muscle car in your garage.
Wow, are they like? They must be like 240 volt or something.
Oh, they're redonkulous. I couldn't even tell you. They're probably honestly 480,
like 600
but
volts or something.
Yeah. I couldn't tell you, but yeah, they definitely had a lot of power. And then we had jump packs, and that was the whole thing. Is like, oh god, the locomotive's over here and it's dead. Go jump it. Go take the golf cart that's got a battery pack mounted to it, basically.
That's crazy.
So Con, I've made it to another industry, and I see you've appeared on my tender, and we haven't even said what we're doing this episode at all. We've just talked trains.
I thought we did.
No, we didn't. People don't know what we're doing.
I moved the plank cars at the smelter.
Right.
So the plank cars are with the Class 48 over there in the smelter line. We're gonna go to the iron mine and pick up some iron because we have some iron, and we need to bring the helper back because we brought it to the roundhouse for the photo op, and now it's gotta go back.
So we've just been shoving it everywhere because I wanted to watch the gears melt.
Because that makes sense. So we're just gonna bring it to the iron mine and pick up some iron while we're at it, and then bring the iron to the smelter. We'll leave the hoppers here because we have space for it, and we'll bring the plank cars back to the hump yard where they belong. Because there's also an extra log car at the at the buy area.
I didn't even remember to look for it when I was driving by.
Yeah, at some point in time, if my buy command went through it last episode, I don't know. I was kind of like frantically clicking buttons. It might not have gone through. I'm not exactly sure. But either way, good times. Yeah, so we're doing stuff. We're kind of just like this is like the cleanup day, We just gotta clean up all the messes that we've made in all the previous episodes,
Right. Well, I mean,
gotta get all that working and
no more Kenosha's, please. Right.
Yeah.
Last episode there were none. It was just because we
I already
built
had
stuff,
a little bit of a kerfuffle with the switch here, but it's fine. You didn't notice. You didn't notice.
Mickey's just gonna have to edit in "Smells Like Kenosha" somewhere in the middle now.
Look at this.
Oh god, he's making a smoke screen. I can't see.
Just
I can't see the particles.
Gotta let people know that we're on the way.
Good god. Yes. Much smoke. Much wow. Yes.
Yeah, we're burning down the forest as we go.
It's fine. It's fine. Hey, there. Oh, look, it stopped. That's magic. How'd you do that?
I just turned off the engine. Dude, I feel like if you actually ran a gear train like this, you can't disengage the gearing, right? So if you were shoving it faster than it wants to go, wouldn't you just wear the living bejesus?
Oh yeah, you'd ruin it. And you could disengage it. It's not like, oh, there's a disengage button. It is, we have wrenches and we can disengage it.
Yeah, physically unbolted or whatever.
Yeah, and so if you really had to take a climax dead somewhere, like that's what you'd do. You wouldn't do this, but we got places to be and climaxes to ruin, so you might as well just go for it.
Yeah.
So
those pistons are they're shot at this point.
It's fine. You don't need pistons or rings or gears or stuff.
Kind of crazy.
But, not crazy like the Crazy Eights, huh?
No, I love the look of that engine. It's the shiniest we have so far.
It's really definitely the shiniest one. I was noticing that when we had them all lined up for the roster shot. And I love the big stack. The big stack is it's a vibe. I love it.
So how often we talk about the big stack? The point of the big stack is to cache ash and like sparks and stuff.
Right.
Sorry, just dying. Need to drink some water. It's important to hydrate.
It's fine.
Kids.
Hydrate before you dehydrate, everyone.
That's what happens when we talk for 2 hours and forget to drink water.
Right.
So, how many cases do you know in the history where locomotives have burned down forests?
Oh God.
Because they just spewed a bunch of crap and lit a forest on fire. Is there any,
there's no end to like possibilities of that or that sort of scenario happening. Like most recently, there was a really recent one that the court ended up ruling that it was the Durango and Silverton's fault, if I'm remembering right. But the 416 fire in Colorado, that was a really nasty wildfire a couple of years ago, got blamed on the railroad. And whether it was the railroad or not, I don't think anyone will ever truly know. But the coal-burning engines do toss out hot cinders, and they have and can start fires. I've had, at the museum, we've had the 20 start 4 fires in one lap one day during Polar Express. And it was right at
like the brush that you guys have.
the little leaves in the gauge, something falls out, the ash pan sets the leaves on fire. It's not a big fire. They burn out super quick, but like you get the right mix of conditions and stuff. And
their kid gets caught on fire. You, just,
it's fine. It's fine.
It's fine.
So I mean, it's just kind of the nature of you're operating a mechanically forced campfire with coal or wood or whatever it is, and it puts out embers, and there's definitely times in history where wildfires have been started that way.
There's no foolproof way to catch embers. Like they all use like various screening methods and things like that.
You can try a lot of things, and the Durango and Silverton, to their credit, tried a lot of things to try and mitigate it. I mean, so the K36s that they were running had a cyclone front end, so they had a special front end device in the smoke box that causes the exhaust to spin, which means it's less likely for the cinders to fly out while hot because they spend more time traversing the flak.
No dust.
Right.
It's true. They use a cyclone, and then all the dust goes to the outside because of centripetal force. So
exactly. It's kind of like that, but you still want to eject the cinders, so you don't have to clean out the smoke box. They just spend more time in the stack because of the swirliness.
They burn out. Basically,
they burn out before they go out. Is the thought, but when you've got a locomotive working tonnage, I mean, it's got a significant amount of exhaust pressure, and that's a whole thing. And so that wasn't enough, so they added spark arresters on top of the stack as well, because the Rio Grande, when they added those Anderson front ends, the Cyclone front ends, they took the spark arresters off because they didn't need them, and the forests were managed differently in the industrial era, and there was less chance of sorts of things like that, so less chance of wildfire. So it never really caused too big of a problem for the railroad. But anyway, these days, with the different way things were and the way that trees and vegetation had grown and everything, made it more likely, right? So they added the spark arrestor, and then they added a stack sprayer. They added a water pipe around the top of the spark arrestor that would spray a mist of water at the cinders leaving to try and put them out.
Water from the tender.
Water from the boiler, I think it was a valve controlled, so it was hot water, but it would, it would condense to water, and it flashed from. It would flash to steam, but I'm pretty sure that it would condense really quick too, because it was out of a small hole, so it made a fine mist of water, basically, really hot water, but water nonetheless.
Right.
And then that would theoretically put out, and then they followed the train with track patrolmen on a speeder that had water and a hose and everything and fire extinguishers to try and put anything out if it came up. And they still, presumably, as the court ruled, that yes, they caused the fire. And again, we will never know. But that's part of the reason why they've converted their engines to oil, was to mitigate the chance of any more fires. And so they're still running steam, but they burn oil instead of coal now.
Right, and the oil has it's got no ash or cinder, I guess.
Yeah, it's not shooting any particulate. There's still a chance. You still have fire, and there's still a chance that something gets ejected out the stack, because they do have to sand flues, and that sends little particles out to get rid of the grime and everything. There's chances that something like a small piece of fire brick could wear off and break off and be hot and glowing when it gets sent out. There is possibility, but it is significantly less than a coal burner.
What about, I got a question asking about electric steam engines.
The Swiss had them, as far as I know. They had a steam engine with a pantograph that went to an overhead wire and had just a bunch of resistive heating elements.
They got power to heat the steam from where? Because you can't just generate power. You can't use the steam pressure to run a turbine generate, but it's a net negative. You know what I mean?
Yeah, exactly. So it was an overhead catenary wire with a pantograph that runs to it like it's an electric train.
It was it was a steam locomotive that ran off of an electric wire built on the track.
They tried it as an experiment, and apparently it was successful, but they didn't deem it necessary, is what I've heard. Someone in the comments will have the whole story, I'm sure, but
that's so weird.
Yeah, very strange.
At that point, you have to run a whole electric wire for a steam. Why would you just run a electric motor on the train?
I don't know why that was a thing. I really don't. Why would you
be hey, let's tug around all this water weight just to heat it up, which is super inefficient, by the way, because heating everything sucks. And You know what I mean? Like that doesn't make a lot of sense to me.
Doesn't make a ton of sense, no, does it?
It's like the universal heat equation, you know? Like heat is the most useless form of energy because you can't do anything with heat energy. You can only do stuff with the difference in heat.
Right.
Right? That's the magic of it. For example, here's the prime example. If you had a steam boiler running at like 1200 degrees or whatever the heck it runs at, on like the surface of Venus, which is also 1200 degrees, it would not produce nearly the energy it does on Earth because thermodynamics is a magical thing.
You know, I've never thought about that because I've never thought about railroading on other planets, but thank you for putting that thought into my head, Con.
It's true. Thermodynamics, right? It's always delta temperature, right? It's a difference in temperature. So if your steam was the same temperature as the outside air or the same, you know, value on the PT curve, pressure and temperature, right? It wouldn't do anything. It wouldn't actually move the piston because there's no difference.
Right.
How stupid is that? And everyone's going to be like, no, you're totally wrong. It's like, no, thermodynamics is like the weirdest mind-bending math ever. And science, but it's true. It's like temperature is actually useless unless there's a difference between the 2 points. That's how it all creates.
The engine has to be, the boiler has to be hotter than ambient. Yeah.
Yeah. If it's all the same, it won't do anything. As dumb as that sounds.
Yeah. Well, I mean, technically, you wouldn't have liquid water, and you wouldn't be able to have that wouldn't be a thing anyways on Venus. If we're gonna get into semantics, but yes, your point about the delta T is correct.
Yeah. So it just seems silly to me to tow around all this water weight just to heat it up, just to cool it down, just to power a thing.
Yeah, con. But it goes chuff, and it also goes. Right. It also goes.
You said it was the Swedes, right? The Swedish.
I
did it.
I think it was the Swiss.
Oh, it was the Swiss.
I'm not 100% certain, but they also go.
Right. We are aligned the wrong way, so just.
I should probably get in the UI in this impossible to get in UI because this locomotive's programmed poorly.
I somehow threw it through the climax. Don't worry about it. It's fine.
That was neat. Can we just stub into this?
I think you have to be on the other side, but I'm gonna just and the 5 fingers came down from above.
You're gonna Kenosha for that one. I don't care. That was great. It was on the rails before, and then why the re-rail tool counts momentum.
I don't think you can fit unless your engine's on the other side.
You're probably right, but I'm gonna try.
Let's see how far you get. I feel like you have to be on the other side. Oh, is it close?
All right, dunk.
Yeah, no, it's not far enough. You gotta.
All right, well then you get out the way and I'll run around the train then.
Yeah, true. And the 5 fingers came back from the heavens.
I mean, you gotta go down the hill, don't you?
Oh yeah, right. I gotta go down the hill. And the 5 fingers drive down the hill. Hold on a minute. My bad. I'm so used to not being the helper. Hold on. There we go. Oh wait, no. I'm gonna flip this. Guys, don't worry about it. It's the I saw Heist did a video where he was playing with model trains, and he couldn't get his train moving, so
the 050 came down from heaven. Yes.
Yeah, and it moved the train. It was wonderful. I will see you later, sir.
Laters. Don't derail on the way down there, Con. Don't do it.
Oh, don't worry. You'll be able to see my black smoke for miles. It'll be fine.
Pretty much. Where's Con? Somewhere in the valley. Valley's black. Yeah. Couldn't tell you.
All right, so someone was asking too about wood chips, throwing wood chips into a steam locomotive into the fire.
Okay, like to make lots of sparks and stuff?
The comment was like, do wood chips do the same thing in a steam locomotive as they do in a steam tractor?
Oh, I mean, same principle. Steam tractors have less screening and less things in general for spark mitigation than locomotives do, because they're usually working in farms and places where the land is usually wet and things, so it's less of a concern. And I know spark shows are like a whole part of traction engine culture.
So they'll throw wood chips in just to generate sparks.
Yeah, I'm assuming that's what they're getting at. I'm not super educated, despite that being my family lineage, but maybe one of these days I'll take part in one of these things, hopefully.
Do you guys do any of that stuff for the audience or anything, or not really?
No, we try not to burn things down because we're in Colorado and things get dry in the summer. So I mean, we had some guy come up. a friend of a friend showed up and was like, "Hey, I've got a big log. Can I burn the big log in the engine?" And that was a mistake to say yes to. But yeah,
Did it spew a lot of crap?
Dude, it was the 491, which normally like doesn't make any hot cinders come out because the cyclone front end, it doesn't work very hard at our railroad. Like, it's not a big deal. It would just be fine, right? And I have never seen
coal though too. Like, coal isn't going to create nearly as many cinders as wood, right?
Exactly. Well, cinders slightly different, but like flaming bits of wood, yeah, and little chunks, yeah. So I don't know if bits of wood that come out of a wood burner are still called cinders or not, or if that's just a coal burner thing. That's a piece of knowledge I don't have. I'm not as educated on the wood burners.
Oh my god, we're gonna die.
Flaming bits of, let's not burn down the countryside, shall we? Yeah.
Right.
So, yeah, point being, big log goes in the fire door, and I've never seen more sparks come out of a steam locomotive in my life. It was pretty bad. And coal burners definitely can look like that. It's just when they burn really junky coal that they do that. Like, there's great videos of the engines in China running with just junk coal, and it's like, oh, good God, they're going to burn down everything.
You use wood to start all your fires. Like,
yeah, exactly.
You'll start it up with a little bit of wood. And what wood is that? Like, is that like
whatever we can get our hands on?
Oh, really? Like, you'll burn whatever? Like, you don't care if it spews crap out? Is that?
Oh, yeah. I mean, it's sitting idle at the shop, so it's not like it's spewing stuff. The blower doesn't do anything violently enough to dump stuff everywhere, and pretty much everything will fall in the pan. So
crazy.
Yeah. We've burnt scrap chunks of lumber. We've burnt stuff that was broken from other train cars.
Lost and found building items.
Well, we haven't done that. We have done. I think the most strange thing that we fired the engines on during fire up was they misprinted like a run of 100 or 200 books or something at the museum. So they needed to throw them away, and rather than throw them away, they went through the engine. And that felt very strange. So that was a thing, but
I can only imagine someone completely out of context shows up at the museum and sees you guys hucking like books,
throwing books into a locomotive, and it's like, this is
like, what are you doing?
Well, they were misprinted, and yes, this looks very strange, but you know, you gotta do what you gotta do. And why use a paper shredder when you've got the world's largest, compact furnace thing? So transportable furnace. So we've definitely done a little bit of that. But fire up, I mean, it's whatever wood we can get. So we end up ordering firewood usually because we need so much. But if we get scrap firewood, we get scrap whatever. We will use what we can get our hands on.
When you start the fire, I saw one of your videos where you fired up and you threw in some, it looked like pieces of a pallet or something, like these long pallet wood pieces or something along those lines. And then you also threw in like a flaming oil rag. So you just soak a rag in oil or something, or gas.
That's the real start. Good God, wait, what in the railroads online is going on right now?
Oh, I think he's dead.
No, Con, there are strange client-side sadnesses going on.
You have a Kenosha, it smells like.
No, my brain hurts. I'm pretty sure the train is all at the top of the hill, and I am just riding down this locomotive that is not actually moving. I'm gonna keep riding it because I want to see what happens. Oh, look, it's back. I'm oh God. I'm gonna break a land speed record, but this isn't a locomotive really because it doesn't have a headlight or doors. This is just an estranged client-side vehicle. I wonder if it derails. I'm halfway down the hill. You're not gonna see the locomotive. Maybe you won't even see me. Only viewers of my episode will believe me as I careen around this curve at like 35, 40 miles an hour.
I almost have it parked here.
Well, I'm almost to you on this forlorn locomotive that's not really here. So I wonder if my player model... Do I show in one spot on the map on your end?
Hold on a minute. All right, I'm parked up. On the map, you are moving.
Okay, and I'm nearby you?
No, you're not nearby. No, on the map, you're like halfway up at the iron mine.
Oh, hey, look! Look, I'm back. I finally.
Yeah, no, I see your train here.
You,
did you run around it already? Like you ran?
I did. Con, you fixed me. I don't know what you did. You probably got close enough to my train to wake up things, but
yeah, no, I saw you here on the map. All right, well you can back up. You're good. Oh,
I gotta line up and load. Yeah.
Oh, okay. Are we gonna?
Why is the UI this? We're no longer playing with the Mosca. The UI is annoying.
The whole way, you know, just leave the engine backwards.
May as well. Railroad would have run it that way.
You're hooked up the Mosca to the front, like it actually hooked in?
Yeah, you just can't stick the link in all the way. It has to be floating away for a little bit, and then it works.
Oh, weird.
Which is jank, but, you know, details.
All right, well, you might as well shove all the way in to get this first car loaded first, then we'll just back out and keep going. And
sounds good. We'll get this thing loaded, and we'll see y'all shortly.
Yeah, I'll load this up.
Yep. Okay, well, hey, that's a loaded train.
Yeah, it's good. Should make some money. Eight iron cars. We, of course, don't have any cordwood, so, you know.
We won't make any more products yet. We'll have to do another cordwood run.
Yeah, so normal things. No cordwood at the smelter. Go figure.
That's just Tuesday, man.
Yeah, that's just a normal day. Yeah, honestly.
Yeah. So
Con, wow, yeah, your bar is actually disconnected. That's.
Yeah, it's a little silly, but you know, right. Con, remember what happened last time we tried to go downhill with a loaded train?
Yeah, but I'm gonna be your brakeman this time. You just worry about you just stay in the UI because client-side Mario is really bad, and
client-side Mario is really bad.
I'm just gonna 100% brake on the first car already.
That's probably smart. I'm gonna pull against it a little bit.
You can pull against it. You'll be fine. See, this would be easier if we had air brakes, right? And we could just tie all the cars together.
Yeah, and then you just set a setting in the cab, and then the train would just be slow, and it'd be great.
And you put your feet up, take a nap, wait till you get to the bottom of the hill.
Pretty much.
You know?
So some days on some railroads, I mean, that's the thing that happens. There's a great story from the old Grand, the Rio Grande, where tail end crew riding in the caboose, conductor, brakeman, you know, sitting there doing their paperwork, train's slowing down, whatever, and train comes to a stop in the middle of nowhere, no whistles, no nothing. What the hell? So they walk up to the head end of the train. Engineer's asleep, fireman's asleep, locomotive's sitting there with, like, you know, half boiler pressure. It finally sitting there with, you know, the Johnson bars kicked forward, the throttle's, you know, wide open, and the engine ran out of steam. You know, it just equalized against the hill and was just sitting there like, yep, can't move anymore.
Amazing.
It's like, bruh, wake up. We got places to be, literally.
If you look at like a modern day train where you tie all the brakes or whatever, right? Do they have, is it like a cruise control in a car? Do you go like with a modern day locomotive, you be like, hey, I want to go 60, and it'll go, great, I'll do whatever I need to do, like I'll brake or I'll apply throttle to stay at 60, or is it just?
No, not really.
It's just, it's still, like, you have a speedometer, but you still have to control the throttle and the brakes manually to get it at that speed.
Yes and no, depending on the railroad, and it's kind of weird. So certain locomotives are equipped with what's called Trip Optimizer now, which is a computer program that runs the throttle based on the subdivision and tries to optimize fuel usage and power and speed.
Right. Anyone
who's ever run with it will say it's a pile of garbage. Hi, all you engineers that are in my comments. Make sure you corroborate that for me. But you put the throttle in notch 8, and then Trip Optimizer theoretically takes care of the speed, at least on the power side. And then PTC will slow you down, but it'll ultimately stop you unless you react and recover the penalty and everything. So there's no like actual speed control. There is throttle control with one system, and then brake control with a second system, and they're separate.
That brake control system, that's the dead man switch or whatever. It's like you have to hit the button every so often.
No,
or else
so that's the alerter, which is separate from PTC. PTC is a much more advanced flavor of that. The dead man switch is the alerter that you have to tap every now and again if you haven't moved a control in, you know, whatever it is, 20, 30 seconds. It'll start to yell at you, and if you don't acknowledge it, it'll dump it.
Every 20, 30 seconds?
Yep.
So your whole job is just like pressing a button.
Yeah, or moving controls. I mean, if you change a throttle notch, it'll cancel it out or two. But yeah, it's it's a whole thing.
It's kind of aggravating.
Yeah, it's a lot of fun, isn't it?
Yeah, that's like the make sure you're awake alarm.
Well, that's what it is. You realize you got nice sidewall heaters, cabs hopefully insulated, not too drafty, not too bad at weather stripping.
Got Xbox hooked up to one of the TVs in there.
You're going down the railroad, and it's lulling you to sleep as it bounces side to side, rocking you like
Call
it's
of Duty with some noobs and just like
Yeah, you wish.
I can't drive the train right now. I'm on a kill streak, man. Calm down.
I want to get that tactical nuke, man.
Yeah, exactly. I get it. I know how it is. All right, so what's the longest a train trip like you'll be on as an engineer in one? It's like, don't they have a limit? It's like 12 hours or
12
something?
12 hours is the hours of service limit.
Right.
And there are times that it goes over and stuff happens sometimes. And modern days, it's really uncommon that you really have to go beyond that.
Well, they'll just swap, right? Like they'll just get a replacement crew to come in. And so what happens if you're driving a train, let's say across the country, and it's like, we live in a big country. You're going from east to west. It's like a 3 or 4 day trip, right?
Lots of crews, yeah.
They just pass because you're not going to be able to park, let's say, like a 2 or 3 kilometer long train just on a line somewhere. Like,
yeah, you can. Big sidings.
Oh, there are big sidings.
There are big sidings. You can. I mean, some sidings are too big for the train to be part, or the trains are too big for the sidings, rather. That does happen. But there are places to stop the train, spot the train, not block things. But the reality of it is your crews are trained for a certain stretch of track. And so your subdivision or the couple subdivisions you work on out of Denver, you know how to go north out of Denver, west out of Denver, east out of Denver. So, all of the ways the railroad runs, to the next big terminal. And that's what you know. And so you
you're
run...
just standing off trains all the time anyway then.
Yeah. One crew does not take a train across the whole destination unless it's a short local these days.
Right. That's interesting.
And relatively, I mean, it's pretty much the same thing back in the day too, because it's all about knowing your territory. You have to know the track.
If you're
like
an engineer, you don't have like one locomotive that you're attached to, and you're like, this is my locomotive.
No.
There are many others like it.
Back in the day, in the 1800s, yes. But I mean,
you had one locomotive, and that was your locomotive. And
1900 onwards, and that date's not a hard 1900. It's somewhere late 1800s, early 1900s. The railroads made the change to like pools of power and things where you got assigned a thing. But back in the early days of railroading, and you read the stories in the books about the old days on the Denver and Rio Grande. I mean, if the guys talk about that was my engine. The 402 was my engine, and they were taking care of it the best they could.
Don't touch my engine.
Don't touch my engine. Don't break my engine. They would try and steal more oil or make new oil, each engineer, to try and keep their engine in the best shape they could. And like, there's stories in Little Engines and Big Men talking about, that time a snowslide came and knocked my engine down the mountain, and it had to go to Salida for repairs for 6 months, and I was stuck with this piece of crap while it was getting repaired. And
it's like the rental car,
Exactly.
Nobody likes the rental car.
And so it was in this era when these engines were shiny and pretty as the Crazy 8 is right here.
The engineer is the one who owns the engine.
Yes.
What about the firemen? Is that firemen are just universal? Are they like golf caddies? You just kind of like...
They kind of are, actually, yeah.
This is your fireman for the day. His name is Billy. He's got 6 years experience as a fireman,
Usually,
and then you're like, oh man, I wish I had a fireman from 3 days ago,
Usually they would be assigned like a bid job, like you bid onto the Gunnison job, or you that's not one of them, but whatever, you bid onto this branch line job, this switch job, this passenger train job, and the engineer and conductor and fireman and everybody would kind of be assigned together, so you typically work with the same crew, although it was much easier to rotate and change firemen versus changing engineers, because the engineer was really with their locomotive, unless things were
and then conductors
doing things,
nobody cares about conductors. They just kind of come and go.
No, so I mean, they were all assigned like jobs as crews together. So you were the conductor on the San Juan passenger train, or you were the conductor on this whatever coal job or this etc. industry job, and like that was the bid job, and that was your job, and it left town this day, these many days a week, and that was the way it worked. And you were a team together until someone hired out to a different spot, got fired, died, whatever,
Got killed by the natives that were robbing your train?
Well, I mean, that's probably in really rare cases, but I'm sure there's times when that happened.
So what happens if, like, the train crew is in the middle of nowhere and, like middle of nowhere, like 10, 15, 20 miles from any sort of people, and there's no telegraph office or anything like that, and they were the only train scheduled for that line of track, so nobody's coming, and, like, something critical broke on their steam engine? Are they just walking 10, 15 miles to...
Fix it or walk.
That's
and
pretty much it.
Dudes got pretty ingenious at getting stuff over the road. I mean... You would be surprised, like, oh, we broke XYZ. Okay, run it on one side. You broke a piston on the one side? Okay. Find a way to
run the whole steam train on the other side only and just kind of, like, hobble their way back.
Get the engine back, try and get the cars in a siding. You broke a rod on one side. Okay, well, undo the other rod on the other side so that you're not running it as a 270. You know, make it a 2260.
Oh my god.
And then, you know, drag it into town. See if you could fix it. Some of the nuts are the same size rod to rod. Like, you need to steal one from somewhere else to make it so that you can make power happen. Do it. Do whatever you can. That's why they're engineers. Fix it. Make it happen. Get across the road, you know, because you're not going to get to sleep, you know, or you're walking. And that would suck. So, but...
All right, I'm going to throw this switch for you.
Get the switch, and then we'll come unload this here. In the later days, they got phone booths pretty regularly placed, and telegraph booths pretty regularly placed, so that became less and less of an issue. But definitely times in history where that happened, and you had to fix it and take care of yourself and get the train back moving again.
See, I still wonder. I know there's human history, human behavior. As much as we like to think we've evolved as a species, we really haven't. And
right.
I like to think that back in the 1900s, you know, the steam days, there was definitely some guy, right, that was like, you know, on any given railroad, there would have, let's say you're talking like the, you know, the Denver and Rio Grande or whatever, right? There would have been some guy that, like, some employee, some engineer that just had the bad reputation of always wrecking something. You know what I mean?
Oh, I'm sure.
Wouldn't it be great to interview that guy?
Right. Who's the bad guy? Who's bad luck?
Here's the guy who just, no matter what job he's on, something goes wrong, and we just don't know why.
That is my friend Leighton, who we all know and love on the channel, and him in photo charters. He has been, we couldn't believe it. We went on the photo charter at the Durango and Silverton this past weekend, and the only thing that broke was a valve shook open on the tender, and the tender started to leak water, and they fixed it like super easy. Yeah, that one. I'll pull ahead. It's fine.
Yeah, I'm not gonna risk.
Yeah, don't throw us. We're Kenosha free right now, Con. But yeah, Leighton's been a part of photo charters where, like, a locomotive blew its cylinder head off. The blast pipe fell apart in a locomotive. The blower pipe fell apart in another one. Like, he has experienced many cursed charters, so we give him a gentle ribbing for that. So
Leighton is the guy that would be in the books, the history books.
The history books is the guy that broke things. Con,
every time Leighton went, you'd be telling your kids one day, and it'll be what happened. You'll tell your grandkids, and you'll be like, "Let me tell you about the time we had Leighton on the team, and
the train broke because Leighton was there." Yes, basically.
And then Leighton left and the train stopped braking, so we just assumed that they were correlated, and that's sort of what happened.
Basically. How much money do you have, Con?
I have $1,683.
Okay, so you are the keeper of the wallet these days, so.
I am the keeper of the wallet. You are going to have to unload this and then push it forward so it just sits here and then run around.
You are going to have to unload this.
And
then I will shove
you
it
have
forward,
to turn your locomotive around.
I mean, I guess we should probably do that.
Or we can just keep going back in reverse all the way to the shop. It really doesn't matter to me at this point.
Doesn't make a bit of difference, really, does it? Yeah,
well, I have to shove all the plank cars with the Class 48 onto the track.
The lead, yeah. That would make the most sense. And
then you can just turn around. All right, I'll get this. There we go. Oh, it's going to start. Perfect. It's probably a good enough speed.
Try and just keep it working lightly here.
Yeah. Doing those live unloads, you know?
Just watching chuffs and puffs.
I love how the coal pile can support 1,000, and it's like you never see it move, and I've never even seen it above 100.
Right. I've seen some
like,
guys have it full, and it's a decent sized pile when it's full, but it's like, how many?
You have to run
like
100 cars.
100
of coal,
cars
like,
of,
that's a
of
lot
iron ore. Yeah.
Yeah, or iron ore. Sorry, yeah. But the coal pile at the ironworks, same thing. Is 1,000. It's a lot of material. And then on top of that, you need all the lumber and planks getting up the other way to get that material in the first place. So it's just...
It's a lot of train to move.
Yep. Good thing we got that 2% line, though. I'm gonna fix up.
Yep, we're gonna have some freight to move,
300-meter
man.
leads on it, and then we'll be able to really move some big freight, you know?
Yeah.
It'll be perfect. Someone shared a screenshot in my Discord of a 1% line leading from the smelter, and they had like 4 spirals wrapping around the smelter just to get out of the valley. And I was like, good God, like the amount of train line that you have to run.
No thanks. So we're all
Just
unloaded, yes?
Yeah, we're good. Just to get 1%.
Stick these in a hole, rotate out. You go kick the cars.
You can honestly just drive forward and then stop once they're in the lane that you're in.
Yeah, that's what I'm gonna do.
I'm just gonna give this a big shove, and it'll coast all the way out.
Yep, and then I'll go spin my choo-choo the other way.
Yeah, cool. Then we'll head on back. Easy mode.
I like how most of the Mosca actually has hitboxes on the running boards. That's a nice feature.
Yeah, I like that you can walk up top. It's kind of nice.
Yeah, it's a nice thing.
Right next to the boiler.
So that's what the running boards are for. We've been taking apart the 346 for its 15-year inspection, 1472-day inspection, which is 4 years of service, but you have to do it every 4 years of service or every 15 years total. So whichever comes first. And we've been taking like handrails and stuff and covers and handles and things off, and it's like, this is becoming more and more of a pain to work on.
Is it with those running? You won't ever go on those when the train's moving, though, will you? Like it's always only like
you
for
hope you
purposes?
don't have to. There's definitely been times in history when people have had to. I have never had to.
What would you possibly have to do though, like while the train's moving out on top of the boiler?
If your sand got so low that it uncovered the traps and you needed to stir the sand around in the dome to make sure you're getting sand to the rails. If your bell stopped ringing and you needed to fix the air ringer on the bell or oil the bell or something. If your check valve got stuck open on the boiler and you needed to shut the check valve manually. Otherwise you're blowing...
Climb out.
You're blowing
on
everything.
A 6-inch wide platform and hope you don't fall off.
Well, I mean, yeah, I mean, they're more than 6 inches wide. And depending on the engine, well, I guess some are only 6 inches wide, and you use 3 points of contact and try not to die. You know, it's fine. Some are pretty generous, though. Like the running boards on our big Mikado 491, they're actually very spacious. They're really wide. So there's plenty of foot space.
All right. Come on in. Turn around.
Oh, hey, look, there you are. Ready to turn me around.
Spin your engine.
Yes, spin me.
All right, well, you gotta get on the thing first.
I'm working on it, okay? Try not to run off the end here. This thing doesn't have as good of brakes as the Glenbrook, so I'm not about to yellow it.
Dude, I've got some crazy force here with my arms. Like, look at this, man.
You're standing on the table and it's rotating.
Yeah.
Whoa.
Well, that's how it works. You just push it and, you know.
You push it and it goes. Yeah.
It goes, yeah.
It's one of the silly things. Makes sense. It works. And I do like the design of this turntable, this gallows turntable. It's pretty with the A-frame and everything.
You were saying, though, it's much more common to have Ys everywhere than turntables, right? Like it's...
Yeah, turntable's a pretty major facility and bearing and things to maintain, and a Y is 3 switches.
Right, and like if we had really short, curvy, tight switches, like that's just
you'd really be able to stick it just about anywhere, whereas not so much with the current gigantic switches.
Right.
I need to do the math on these switches, but I want to say that they're absolutely ridiculous. Super long.
You are spicy speed.
Yeah,
I
man.
thought you didn't want a Kenosha today.
I don't. Where are the cars? You know where the cars are, right?
Yeah, but like, are you not worried that you're gonna derail?
No, we ran this thing full speed all over the place yesterday, and the only thing we derailed were the cars. And by yesterday, I mean a couple episodes ago.
The time all melts together.
It's all the same, man.
All right, the cars are coming up.
I see them.
Good, 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 good. All right. Back more. You're not.
You can't hold the slider in place. I was trying to hold it, and it was, you have to click and let go.
All right, you're good. You're going to untie your brakes. Yeah, you're good. That's it. You got to hit. I'll get that switch up front.
I'm still in joust mode as well.
I'm a switchman when you're running a locomotive. You're going to just slow down, wait for me to run up ahead, flick the switch, and then, like, how long would it take me to tie a switch, though? Because you have to hand crank it over, wouldn't you? Oh,
yeah, so you move the switch by hand, but we wouldn't let you run up front. The old saying is a good railroader is a lazy railroader. You would ride on the engine with us. We'd pull up to the switch. You'd tell us to stop shy of the switch as close as we can get you, and then you'd get off, only walk the short distance that you needed to.
Oh, so they would full out stop the whole train and just start it back up from dead again?
Well, back in the day, they probably would have got off and on moving equipment, but they would have gotten you closer so you wouldn't have to run, because running on ballast sucks. Walking on ballast sucks. There's stuff to trip over. There's ties. It's slippery. Ballast is hard on your feet, and doing that for years and years, like, if you can avoid it, it's really encouraged to try and avoid it and ride everywhere you can.
But to them, it's they don't really care to have to start the whole train's momentum up again and rebuild all that. And
well, I mean, you do and you don't. I mean, if you got to go a different route, you got to throw the switch. You got to throw the switch, and before you have computerized, switches and things that can be thrown remotely, somebody's got to get out and do it. So you either stop or you slow down enough that you get off and you run out ahead and throw the switch, and then we keep going. But that's kind of uncommon, because if you fumble the lock, then, well, guess what? We have to back the whole train up, and rather than start it extra once, you're starting it extra 3 times or 2 times. So
on modern day locomotives, is that like the automatic switching you were saying? Like, there's obviously like automatic switching stuff on modern day locomotives. Do they is that like something that the operator, the engineer of the train has to be like, hey, I want to switch this switch, and then it will remotely switch? Or is it all just like done automatically to a schedule, or there are transponders on the train? Like, how does it know where to put each train?
It depends. So when we're talking like freight railroads and stuff, it's all dispatch. It's what's called centralized traffic control, where in the case of BNSF, there is a American football stadium sized room in Fort Worth, Texas, where all of the dispatchers, save for like a handful of special cases, all live. And you call dispatch and say, hey, we need routed into here, and dispatch has the schedule and knows where the trains are going. And they're probably doing that ahead of time.
They're the ones who control all the switches.
They're the ones that do it all, unless there's a problem with the switch, and then train crew or the MOW folks need to take care of it manually. Yeah.
Wow. That's crazy. It's literally like they're basically playing with a giant train set from.
Oh yeah, exactly. From
like halfway across the country or whatever.
That's the whole fun of it. So the difference with like transponders and stuff like you're talking, that's actually in transit applications. So I designed signals for transit for a while at a Seattle Sound Transit, and the way that those work is that they have a loop, an actual loop of wire in the track that is called a TWC loop, and it looks like a number 8 because it's actually 2 crossed over loops of wire, and it transmits a 19-bit message between the train and the wayside. TWC stands for Train with Wayside Communications, which is an extra W, but whatever, who cares?
So that wire is connected all the way back to some central hub location?
It's connected back to the nearest signal bungalow for that location. Right. So if you get to an interlocking, say you get to a junction point, and your options are to go to Seattle or Bellevue, which will be a thing at some point. But anyways, and you get to the junction, and your train is programmed, and your train tells the wayside, hey, I am train XYZ, I am car XYZ in lead position, my destination is this destination, please route the switches and clear the route this way. And then the signal system makes that happen, and it makes it happen while they're going 55 miles an hour. So the train never has to stop. Switches automatically route. Signals automatically clear, assuming that it allows them to. Sometimes
I'm assuming
it
signals
won't, but
still have like the manual indicators on top, so that you can look at them from a distance and see what direction it's flying to.
They're not manual indicators, but they're LED.
Okay. Gotcha.
And again, it depends on the application. Like on the big freight railroad, you'll have a green signal for proceed straight. You might have a different aspect of flashing green or flashing yellow or a yellow or any various thing to say, oh, you're going to turn. And then in transit, we have weird signals that are bars. And if you have a white bar that's vertical, it says you're going straight and you're cleared straight. Or you have a slanted white bar that says you're turning left, etc.
So what about, like what happens if you've got like a power outage and the signal house doesn't have power?
They have battery backup. And they have hookups. If your
battery backup runs out?
They have hookups for backup generators. And if you get past that, you're not running trains.
Wow, okay.
Particularly in transit, because transit is electrified. So if you don't have power, like, at the end of the day, you're going to run out of traction power before you need to be able to do anything else. In the freight railroad, I mean, you can run those things on battery backup forever because it's just 12-volt DC. It's not anything rocket science. You basically hook a car battery up to it, And they have the same thing. They have some battery backup for a certain amount of time, and they're ready for a certain amount of switch moves with electric switches, and they can have the signals run for so long. But at the end of the day, if you lose power, a dark signal is a red signal. It means stop.
Well, that's unfortunate.
And then that would be enforced by PTC on the modern day railroad. Red equals dark. There's no power. PTC can't talk. PTC says, ah, and then stops the train. So...
crazy.
That's one of those fail-safe things of everything.
I feel like the people who do train traffic controlling, I feel like they're in the same boat as aircraft controllers, like just extremely stressful all the time, thankless job.
Yeah, I've never had to work with dispatch, and I know there's at least one dispatcher that watches the show who's reached out and said, like, hey, we should talk about dispatch and stuff, and I should probably find them again and reach out again. So if you're out there listening, let's chat and see about talking about dispatch, because that would be a really neat thing to talk about.
Dispatch and air traffic control, it's just one of those things. It's like, it seems like it's very, very stressful, and it's very much required.
Sucks. Yeah,
but it just sucks. Like, it's just it's just a painful experience to have to deal with.
And I've also never heard anything nice from a train crew about dispatch. Like, no one ever says anything nice to say about dispatch.
Right, but like dispatch is busy juggling 5,000 trains all at the same time. So like, you and your one little crew is irrelevant to them. Like, it's
yeah,
not irrelevant, but like you are ants in the grand scheme of the colony.
I would imagine that it's a lot less stressful for railroad versus planes, because you're not worried about flying things and all that, and we have all these signals and stuff to protect trains, and it's more of a logistical puzzle.
Planes have that too, actually, where they've got transponders where they'll talk to each other. So a plane that's about to hit another plane will actually steer out of the way.
Really?
Automatically, yeah. So there's some documented cases though where I know people are going to correct me, but there's some documented cases where that has failed, mainly because there's a combination of pilot error or not. But there was a case, I think, where the two planes were coming at each other, and then the air traffic controller was saying something different. So the one pilot turned his system off, and then they clipped each other as a result, or something like that.
Gotcha.
And then, of course, you run into the issue with small planes as well, because they don't have that system. These are only on, like, bigger jets and things.
Right.
So, like, smaller planes won't necessarily... They'll have a transponder that squawks, where they'll be like, I'm a plane. This is how big I am. This is where I'm moving. This is my tail sign, But they won't necessarily have the... I can't remember what it's called. There's a name for it, an acronym for it that moves planes out of the way from each other. But, yeah, it's there's some extent. And then, on top of that, there's, like... if you go on a flight, you might notice that when you're flying one way, it'll be flying at like 40-something thousand feet. When you're flying the other way, it'll be like 38,000 feet or whatever. So they do have these windows for traffic, right, where they keep them a couple thousand feet apart.
Gotcha. Yeah, I've always wondered that, like, how do they pick the cruising altitude? And I guess it's a lattice network of other planes.
Yeah, my dad back in the day used to have a pilot's license, and he taught me a lot of this stuff, and all the not like a commercial pilot's license, just like a recreational, pilot's license or whatever. But you still have to learn all the stuff and the holding patterns and things like that, right? Like when you're waiting to land in an airport, there's holding patterns, which is basically like a big lazy oval that you do to stay out of the way of planes landing and taking off, but also, you know, maintain your altitude and blah, blah, blah. And yeah.
There's your log car, Con. There it is.
Yeah, it is. Oh, look at that. Perfect. Unnamed log car. Wonderful.
Well, I mean, I think the starter ones we had were all unnamed too, so it's probably fine.
Yeah, no, it's perfect. It'll just fit right in.
Fits right in, and now we just have a weird number of them. So thanks for that.
But yeah, I'm sure the plane guys will correct me. But it's kind of cool what planes do, and they're like when they're monitoring like plane traffic and stuff and like their movements and things, like planes report so much data so often, you know, like it's just so much data that's coming from like direction,
only
speed,
imagine.
altitude, all that stuff, right? So it's like, yeah, it's pretty nuts. I'd love to get my pilot's license one day, but it takes a lot of time and it takes a lot of money.
Yeah, I can imagine that.
Yeah, and then on top of that, you have to like, I mean, obviously I wouldn't have a plane, but you have to like find the time to rent the plane. You have to get all your flight hours in and stuff. You know, it's a big process.
Yeah, I can only imagine just how much goes into that.
Yeah, would be cool though.
All
right, well, perfect. Another mission accomplished.
Back at the hump yard, we gotta stick the cars in the hump, but we can get that.
Oh, you
done.
want to hump? Sure, we can hump. We don't have an engine on the lead track.
We don't, so we're gonna have to run around all the way, and it'll be a whole thing.
Yeah. Well, we might as well save that for next time, because we're gonna need to probably bring cordwood and/or planks, and/or we might just end up bringing these again.
Yeah. So I guess we'll figure that out. But as Kano said, let us know what you think in the comments down below. Really fast.
Yeah, no,
right?
that's exactly how I say it.
That's
and
how
we'll
it
see you all
goes.
next time.
Yeah. Bye.
Just like that. Perfect.
Yep.
10 out of 10.
5 out of 7.